All right, let's just get into some hypothesis test questions. So, listen, if you haven't already, get a pen and paper. Do the questions with me. Pause it before I start. Try to do it. See what you get. If it's wrong, make sure you watch the whole, each step, which I do. If it's right, obviously just move on. All right. So what I've got is the great thing about hypothesis test questions is firstly they're always big marks, minimum of 5, right? Most likely 6. And they always follow just the same progression. It's the same 6 steps every single time, which is great. So as long as we get comfy and we get really good on doing these 6 steps every time, you got full marks, man. You can't ask for more. So let's just kind of jump straight into this. Let me explain the 6 steps. Number 1, you always want to write the binomial distribution. I don't know why I got that 1 there, by the way. Didn't want it there. Okay, I'll see you in the second one. Okay, number 1, you write the binomial distribution involved in the question. Number 2, we do the setup. We're going to write H0 and H1, null and alternative hypothesis. And we're going to label the observed value and the significance level as well. We're going to do a quick sketch just to get clear on what we're testing. We're going to test the observed value. We're going to check is it in the critical region. And we're going to do a conclusion with context of the question. I know that might kind of seem like, what the hell are you talking about? Don't worry about that. As we go through these questions, all will be revealed, as they say, all will be revealed. So let's have a look at this question. This, by the way, is on page 324. If you got the CGP book, the year one. So you can look along there as well. Otherwise, I'm going to go through it anyway. So, okay, a student believes that a 5-sided spinner is biased towards landing on 5. The student spins the spinner 20 times. That's going to be our number of trials, our n, okay? And it lands on 5 10 times. That's our observed value, man. Like, it's like out of the 20 times, we've got 10. And we're going to test, hey, is that too crazy? Based on the fact that it should be, we'll go into that anyway, yeah? So your observed value, which we usually call like x equals 10 or whatever, but observed value, okay, it's 10. 5% significance level, test hypothesis spin is biased towards landing 5. Okay, so the first things first, the binomial distribution, there's 20 trials. We're literally kind of spinning it 20 times. And the probability we expect for it to kind of land on 5 is 0.2. That's what we're going to actually be testing as well. And by the way, you get 1 mark for just writing that. That's what one of the marks is. So next one, let's get to the setup part. So setup, okay. You want to write your H0 and your H1 again. Not again, just to start with. So what we're testing is, hey, does the... so by the way, we've got a 5-sided spinner. So, obviously the probability of it landing on 5 is a 5th. So that's what we're testing. I'm going to call it 0.2. I know I preach a preferred fractions, but yeah, man, decimals. Okay, now we've got to test. Check like what alternative hypothesis is. Remember, 3 choices. Is it not 0? Sorry, 0.5. Is it greater than... What am I talking about? Sorry. We think our 3 possible ones is it either not 0.2? Do we think it's bigger than 0.2 or less than 0.2? What are we testing? Now, the answer is actually in the first line. The student believes that a 5-sided spinner is biased towards. And obviously, if he thinks it's biased towards, he thinks you're going to get 5 more times than you should. Okay? So he actually believes that the probability of getting 5 is greater than 0.2. That's the whole point of the bias thing, yeah? Okay, so I like to write the observed value because that's what we're going to test in a bit. It's 10. And significance level is 5%. Let's do a little sketch and get clear on what we're actually kind of like, the way we want to test. So quick sketch of the distribution. We're checking to see, this top 5%. We're checking to see, well, where is 10? So obviously the thing will peak. So, if you did it 20 times and the probability of getting each one is 0.2, well, 20 times 0.2 is we expect it to come 4 times out of 20. So we've seen that it landed 10 times. So we're saying, hey, does 10 land somewhere here? So like all the probability of above there is actually bigger than 5%, because then it's not crazy. Or does it land, the probability of it being bigger than 10 is it less than 5%? Okay, because then it is too crazy. Then we're gonna, if it's too crazy, we're gonna say, yeah, no, we don't believe this. And if it isn't, we're like, yeah, cool. Okay, so here's the deal, right? We've got two scenarios which can come up. If we find that the probability of being greater than equal to 10 ends up being bigger than 0.05, we're saying it lands outside. So this will be not critical. Okay, and if it lands below 0.05, that means it's in this critical region, and it will be critical. So that's just our sketch. So that's just like our little sketch and our test kind of thing. Now we're actually going to test it, and all the test involves is we actually go bothering to find out what is greater than equal to 10. Okay, just like a quick recap. Remember, we can only use the less than or equals to, either, you know, like in the calculator or using the tables. But to be honest, I mean, Jesus Christ, man, the calculator is the way forward. So the first thing we need to kind of understand is how do we do that. So, okay, back to the binomial stuff, we write the two numbers either side. So we want all the numbers, including 10, that way. So we want to kind of go, so the probability of greater than or equal to 10 is going to be 1 minus all of these numbers. So x greater than or equal to 9. Okay. All right, so let's find that out. So let me fire up the calculator. Number of trials, 20. Probably is that. Let's find out what 9 is. Okay, this is 0.9974. So our probability of it being greater than or equal to 10 is minus 0.9974, 0.0026. Okay. All right. So now we've got like the decision. Is it in the critical region? Well, you can clearly see here that this is less than your 0.05. So it's in the critical region. And what that means is that means the 10 is in this bottom 5%. I should have drawn this bigger, but you know, 10's here somewhere. Okay. So finally, all you have to do is we just do the conclusion. So let me just explain the context bit as well, yeah? Because a lot of people hate the wordiness of all of these questions. What we've done here, yeah? Here's what we figured out. So we've got this 5-sided spinner, and obviously if you spin it 20 times, if you expect it to land on 5, the hell am I talking about? 4 times. Did I say 6 before? We expect it to land on it 4 times. Is that 4? I hope that's a 4. I hope I haven't screwed that up, man. Hopefully you get it. If it doesn't make sense, come to me. On the fly stuff here. What am I talking about? Okay, yeah, back to this anyway. So remember, so what we've kind of done is we're checking, hey, this 10 times which it landed out of 20, is that too crazy of a situation? God, I'm like tongue twisting myself. Sorry guys, my brain isn't working properly. Basically, we're saying it's too crazy. It's in this really extreme rare scenario, because the probability of this thing happening, of what we've just seen, is like 0.26% or 0.026 as a decimal. That's less than 5% of the time we expect to see it. So what we can say is we reject our H0. So just write that, reject H0. We're not doing that. Or you could write accept H1. And now the context thing, okay? There is evidence. I don't know why they use kind of like, words, which unnecessary words. Evidence that spinner is biased towards 5. Ugh. Bit of tongue twisting at the end, but hopefully that makes sense. And if it doesn't, don't worry. I got plenty of examples for you. Plenty. All right, let's get rid of this as well. And by the way, you know, I can't be bothered to pause the video each time, so feel free to skip ahead, you know. By the way, on YouTube videos, J and K are my favorite way of skipping forward. Sorry, not J and K, J and L. L, tap L, you go forward 10 seconds, you can just keep tapping it. All right, let me get the next question up. All right. Here's a good one. All right, there you go. There's our question. So let's have a little read of this. Pengu Inc. sells stationery to 60% of schools in the country. The manager of, so 60% by the way, yeah? 60%, that's a probably P equals 0.6. Okay, the manager of the thing claims that there has been a decrease. So clearly H1 is talking about there's going to be a decrease in 0.6 in the schools buying this stationery. She rings 30 schools. Yeah, that's our N. And finds that 16 buy. Observed. Test a claim at 1% significance. All right, so first, what is a binomial distribution being tested? Well, our number of trials is 30, and the probability of like picking a school, you know, is 0.6 because obviously they sell to 0. So 60%. Okay, so that's our first thing. Number two, let's set it up. H0 is we think it's 0.6, or maybe that's what we're testing against. And here's the thing, we think in this one it's going to be less than 0.6. Does that make sense? Okay, because there's a decrease. All right, let's write our other stuff. Observed value, so 16, and yeah, our sig level is 1%. So sketch, maybe I'll do a better sketch this time, hopefully, just decide our tests and stuff. Here's a sketch. We're bothered, and I know this looks much bigger than 1%, but I'm just doing it for the sake of bigness. We're wondering, hey, you know, like the observed value of 16, does it fall into here? Is it 60? What have I done there? Does 16 fall into here? If so, we're gonna say that's too crazy. Or does it fall into here somewhere? So basically we're saying, does, with the probability of less than equal to 16, because remember we're kind of testing on the lower side now, we're saying does it fall on this side, is less than that. Is this less than 0.01? Is it? Yeah? If it is, if so, it's in the critical region. So if we find out that the probability of x less than 16 is less than 1%, that means it has to fall in here, you know, so that could be like 0.3%, that would make sense. Okay, so that's our test kind of done. Sorry, not our sketch or whatever. Now let's test. Let's find x less than or equal to 16. This is everybody's favorite one, man, less than or equal to. You can just put that straight into the calculator, no finding anything out, which is lovely. They're saying that's not hard. They usually give you an extra mark for when you do have to change it around anyway, so in a way you probably want it. The answer is 0.855, which is huge. All right, decision, well, 0.2855. That's greater than 0.01. So it actually means it's like here somewhere. Do you see what I mean? It's like here somewhere or something like that. Okay. Yeah, basically not in critical region. So finally we do the kind of like conclusion. Okay, the conclusion is oh no reason to think that. Okay, accept H0. So we're saying, yeah, it's all good. Nothing, we haven't seen anything too nuts or too crazy. Accept H0, and let's have a look. No evidence to suggest decrease in number of schools buying stationery. There you go. That's another one done. Feel free to skip ahead. The next one. Yeah. Example 3. 10% significance. 10%. Okay, let's have a look at this. Proportion of pupils in a school support a particular team is found to be 1 in 3. That's going to be our P. So P equals 1/3. Claims that there is less support. So H1 is the P less than. So it's a one-tailed test again. So we're just taking like one of the sides. In a random sample of 20 students, that's our N. 3 support the team, that's our observed. And we're using 10%. All right. The binomial, or the trials are 20. The probability is we're testing 1/3. Let's do the setup. H0, we're testing, we think it's, or we're testing, is it 1/3? And we believe, hey, has it dropped? We support a particular football team, yeah? We think that's not the case anymore. So the observed value is 3. So we picked 20 people and only 3 people support the team. Is that too crazy for us to kind of believe with the 1/3? We'll find out. Only time will tell. Sig level 10%, all right? So let's do a sketch. It's going to be very similar to the last one. We're bothered about the last bottom, this time 10%. So we're seeing, does it fall into there? So we're trying to, for the critical region, yeah, for it to fall into the critical region, which just means, hey, we're not going to accept our original claim. So we're testing, we want to test, does the probability of it being less than or equal to 10, less than or equal to, because we're only testing this side, is it less than 0.1? Because that's 10%, is it? If so, it's in the critical region. If not, then it's not. So now we do the test. Probability of x less than or equal to 10. Nice and easy, just put in the calculator. It's actually the ones we're testing the top end, which are in any way difficult or whatever you want to call it. It's not even difficult. Um, 3, right? 10. Wait, why have I got 10? My bad, Ged. My bad. What am I doing? What am I doing here? This should be 3. Jesus Christ. 3. Am I on crack or something? 0.06. Whatever, yeah, 0.06. Decision. Ooh, it was close. But no. Well, actually, no. 0.06 is definitely less than 0.1. So, it's in critical region, man. It's in the critical region. The conclusion. We reject H0. So, like, evidence to suggest or support. It doesn't really matter as long as you get the point. So, no, let's go for, come on, man, stupid thing. Yeah, evidence to suggest there is less support for the team. That's it, you know, in terms of that. So we do believe that this particular football team, less people care about it. Wow. What the hell is this? Oh, wrong one, no doubt. I'm glad I did the wrong settings. Bear with me. Yeah, okay, cool. Got it. look at example 4. Alright, so I'm going to cover this anyway a little bit. Okay, wildlife photographer taking photographs of a rare glass frog. He's established over a long period of day that the probability he'll sight a glass frog during any day is 0.05. That's our P. He moves to another part of the rainforest, believing that the probability will be different, not higher or lower, different. That means our H1 is where it's not equal. Okay. So during the first 6 days, he spots the thing on 3 days. So 6 days, right? That's our N. That's the number of trials. And he spots it on 3 days. That's our observed. And it's a 1% significance. So let's kind of get into this. So it's a binomial, six trials. And the probability was 0.05. Let's do our setup. H0, yeah, we think the probability is 0.05. That's what we're testing. But there's there's a belief that, hey, in this different part, we don't think it's the same. So we're saying, hey, we don't think it's that. Observed value is 3. I'll actually use the right one this time, I assure you. Significance level, 1%. Okay, now let's do the sketch. This one's a bit more interesting. So say, it doesn't really matter how it looks like. Now, this is we're not saying particularly, oh, we think it's higher or lower. We're like, we don't know where it is. We have no clue where it is. So it's not like I can just put 1% here because like, well, hold on, I just don't know. It might be less than. So we've got to look at both ends. We've got to look at, is it on the crazy end of either side? It doesn't matter as long as is it in one of them. So here's a mistake which I see sometimes. Someone's like, oh, that's what, so we got to look at 1% there and 1% there. No, you don't, because that would make a total critical region of 2%. So what you have to do on two-tailed tests is you actually have to half the significance. So this has to be 0.5% and 0.5%. That's how we're going to have to test it. And by the way, that's kind of considered, the way you write 0.95% is 0.005, basically what I'm writing. Yeah? So the question, obviously, in critical region, if, yeah, it's in one of those. But we need to actually decide here. So, the question is, hey, are we trying to test greater than equal to 3? Or are we trying to test less than equal to 3? Which one? Okay, and the way you kind of like figure this out, yeah, is by timesing these two together. Bear with me. We find the amount of days we expect to see that glass frog, which is 0.3. So of these 6 days, because the probability is so small, the one we're testing, we would expect to see it on 0.3 of the day, so not even like a full day. So really, that's what it's going to hump. So 3, so that if this is 0.3 here, 3 is going to be somewhere on this bigger side. So it's this one which we want to test, man. That's the one we want to test. Because less than is definitely not going to be on that side. All right, let's test away. Probability of x greater than or equal to 3. So we have to write that as what is that, less than? So if we think of like 1, 2, 3, 4. So we want all of these numbers. So that means what we have to do, 1 minus all of these numbers. So we've got that less than or equal to, the only one which we can actually use. And then it's more or less straightforward stuff. Can you see it's like just the same thing happening like over and over and over and over and over and over again. Okay, the probability is 0.99777, which actually gives you, what does it give? 0.99777. 0.00223. That's actually like a little trick learnt from one of the students myself. One of you guys taught me. If it's you, you know who it is. All right, so decision. Yep, 0.00223 is less than 0.005, which is tiny in itself. Therefore, it's in critical region. Therefore, and then conclusion, you know. Yeah. You reject H0. Yeah. So we have evidence to believe that it's not the probability, you know, we're rejecting this. So we're saying, hey, we don't think the probability is 0.05. So just in terms of the context, you know, make sure you read this thing. So he's saying, look, he believes he believes that it's 0.05, the probability of getting it, but he's gone to another part of the rainforest believing that the probability will be different, and this time that is true. So you just kind of say, you know, like evidence, yeah, to suggest probability of spotting the frog. I'm just going to write probability of frog in other part of rainforest is not 0.05. Simple as that, man. Simple as that, you know. It's the same thing every single time. I guess like the only place where you can maybe kind of, oh man, come on. This is not a good piece. It's not a bad piece of software. Nah, I hate. I'm being harsh on it. Being harsh. Let's look at the exercise questions, which there are 6. So let's kind of pick ones which I think are most interesting. To be honest, if one is interesting, I think what I'll do is I'll pick the less than ones are pretty straightforward. Maybe we can have a little talk. Let's have it. Okay, but let me actually figure out what the hell I'm trying to say. So Charlotte claims she can read Millie's mind. Charlotte, she's got skills, man. What am I doing? I just literally zoned out. Okay, I'm back at a brain lapse. All right, so we're going to pick a question. She claims that she can read Millie's mind. To test this claim, Millie chooses a number from 1 to 5. Come on, Charlotte. Yeah, come on. If you can read my mind, tell me what I'm thinking of right now. But we'll go for number 1 to 5 because we can't make a hypothesis test of it otherwise. Charlotte is right on 4 out of the 5 occasions, blah, blah, blah. Can you see it's a pretty straightforward one? Actually, no. You know what? Let's do this. And this one is actually good. This one got something interesting to it. Okay, so hopefully you got those written. This is a big block of text, so I do need to have extra space. Okay, question 1. So yeah, let's do the. So let's go through this. She can read the mind. To test this claim, chooses a thing from number 1 to 5, and concentrates it on it while Charlotte attempts to read her mind. Charlotte is right on 4 out of the 10 times, so that's your observed. You know, and she did it out of 10 times, so that's your N. Now your probability here is actually quite interesting. Think about it. So there's only 5 numbers to guess from. 1, 2, 3, 4, 5. So the chance of her getting it right by fluke here is a 1/5. So the probability here is 0.2, which is a 1/5. Okay. So let's do the setup. So binomial, it's you're dealing with 10 trials, of which the probability of getting right is 0.2. Okay. Let's do the setup. So the setup here is H0, we know is P equals 0.2. Right, what do you think the alternative hypothesis here? Now, it's as simple as there has been nothing in the question which is said, nothing in the question which is said, oh, she thinks she can, oh no, wait, she can. What am I talking about? Yeah, okay, oh, my bad. Okay, I'm back. Yep. Charlotte claims, so Charlotte's claiming she can read her mind. So what we're saying is we should test that, hey, is it actually greater than 0.2? Is there something about Charlotte's mind reading ability that makes it more than likely, more than guesswork? So that's what we're doing on this one. And that's your part A, by the way. Write down the population parameter. That's what they mean by this. I don't know why they said it horribly. And the suitable null and hypothesis. It's these null and alternative, that one. Define a test statistic and write down its sampling situation under the null hypothesis. Something to do with this. You'll never see questions like this in the exam anyway. But basically, can you see, are the results significant at 5% level of significance? Basically, it's to do with saying test it. So I reckon observed value is 4 and sig level is 5%, which it says here. So right, let's do like a quick sketch. Okay, so we're testing, is it in this top 5% here? So does 4 fall into here or here? So we're kind of saying, does is the probability of being greater than or equal to 4? Is that less than 0.05? That's when it'll be in the critical region. That's where it'll fall into this crazy bit. Okay, so let's test it. Let's find the probability of it is greater than or equal to 4. So remember, we have to get that into the less than equals to. So if we do 2 numbers each side, greater than or equal to 4 means we want all of these numbers. So that means we don't want this one. So we can do 1 minus probability of, take away the numbers we don't want. So let's go into this. Make sure you get the same numbers as me. Alright, I got 0.87912, which means that this is 0.12098. Hopefully I've done that correct at the top of my head. Use a calculator for that one. 8. There you go. Good reason not to kind of do what I do. So okay, now we do the decision. 0.1288. Yeah, it's bigger than 0.05. So it's not in critical region. And then just do the conclusion, man. Okay, so we're going to be accepting H0, which says, hey, we do actually, there's no reason, we think it's just the probability of doing it is right, so there's nothing special. So we have, so remember, this test means what we were testing was, hey, she has no ability. And the alternative ones were, oh god, she does have some ability, there's something special about it, this is more than just kind of fluke. So what we just found is no, probability is 0.2. So in terms of the context, remember, this is about Charlotte's mind reading. No evidence to suggest Charlotte can read minds, can read Millie's mind. Yeah, context of the question. Might as well cross this now. Okay. Pick another question. Two seems pretty straightforward. Feel free to do that. The past being distinctions. Let's just do like 5 and 6. Let's just go straight for the hard ones. Or supposed hard ones. Okay, jump straight into it. All right, 10% of the customer village buy Spotis magazine. So that's our P, isn't it? P is going to be 0.1. I mean, I should read the whole question first and all of that, but it's going to be 0.1. The owner has just opened a new shop in a different village and wants to know whether the proportion will be different. Okay, so that what that's telling me is my H1 is about not. So it's not saying will be higher or lower. One day, 8 out of a random 50 customers bought the pigeon thing. So that's our N, and that's our observed. That's what we're going to be testing. Is that too crazy or not? 5% level. So okay, binomial. How many trials do we have? We have 50 trials, of which the probability we're going to be testing is definitely 0.1. Let's do our little setup. H0, we think, oh, is it 0.1? Yeah. Is it not H1? Observed, val equals 8, sig level 5%. Okay, just do like a quick set so we know. This is a two-tailed test. We're not saying, oh, we only care about whether if it was particularly high or low. We got to look at both sides. Now, remember, because both of these sides have to make up 5%, we're actually looking at when that's 2.5%, and we're looking at that at 2.5%. So what we're now deciding is, hey, hold on, are we trying to test greater than equal to 8 or less than equal to 8? So what we do is we say, what's the highest likely probability? And that's by saying, well, we expect, if the probability is 10% of 50, and there's 50 people we try, we expect there to be 5. So we expect 5 to be here. So really 8 is going to land somewhere on this side. So we actually care about the greater and equals to, okay? So we're saying, so if you want the critical region one, is probability greater than or equal to 8 going to be less than 0.025? Question mark. Yeah. Or by the way, always put a question mark, okay? Because that's like, we want to know that. I don't know if I've done that in the lessons. Having a bit of a mind blank, man, today. Gotta say. Okay. Greater than or equal to 8. So we need less than or equal to, because we can't find that out directly. So we just think if we write numbers both sides, we want 8 and everything above. So we're going to consider, we've got to do 1 minus px less than or equal to 7. Calculate a job now. 50 trials, 0.1. 0.87785. So yeah, so I'm going to use a calculator this time. No heroics. Come on, what have I wrote? Here we go. 0.12215. Decision, yes, not, is it? It's too big. Yeah. So like 0.12215 is bigger than 0.025. Not in the critical region. Conclusion, or whatever you want to call it. We are going to accept H. We will accept H0. So we're like, hey, this wasn't too crazy. So yeah, so it's like no evidence to suggest proportion of magazine buyers is different in New Village. You could have said as well, no evidence suggests that it's not 10% in the New Village or anything like that as well. One more. I know you're kind of thinking encore, oh no, only one. I'm afraid so. There you go. Okay. Pete's Driving School advertises that 70% of its clients will pass the driving test for the first time. So there you go. There's your P already. P equals 0.7. Okay. Haiti and three of her friends failed. 4 other friends did pass first time. She complained that the advertisement was misleading and that the percentage was actually lower. Okay, actually lower. So she kind of thinks it's the H1 is P is less than. Test whether there's evidence to support her claim at the 1% level. So that's the significance. So now let's have a look at this. All right, well, what's the number of trials out of interest? What is the number of trials here? Well, think about this. Haiti and 3 other friends. So there's 4 people right there who had a go. And then 4 other friends did pass. So there's 4 right here as well. So altogether there were 8 trials. But that's quite a nice way of hiding it in the question. The probability obviously of, he's saying, oh, 70% will pass first time. So we're testing that anyway. Let's do our setup. H0, we're testing. Okay, well, let's kind of test your 70% claim. H1, she's saying, nah, I think it's less. Well, let's have a look. Our observed value was 4 people. Remember, 4 did pass first time. And remember, his claim is about the client's passing. So we want to focus on how many did pass first time. And your SIG level is 1%. So, okay, your sketch, just to kind of decide what the hell you're trying to figure out. So we're looking at the bottom, 1% is 1%. So we're kind of saying it will be in the critical region if probability of X being less than equal to 4 ends up being less than 0.01. Okay, that's what it is. So let's test. So let's actually find out the probability of it being X less than equal to 4. Hurrah, it's a less than equal to, so there's no extra work. Not that it's hard. Okay, we got 0.1941. So now we got the decision. So we write 0.941. Well, that's actually bigger than 0.01. So it's like it's not in the critical region. So I think Hattie is being really harsh on this on poor Pete. So like a conclusion, no evidence to suggest pass percentage is less than 70%. There you go. Hypothesis testing. Hopefully that's kind of helped. If anything doesn't make sense, naturally bring it to me.